We've all heard of black holes, those massive cosmic objects that trap everything, including light. But what if I told you there's a theoretical counterpart to black holes known as white holes? While black holes pull everything in, white holes may do the opposite. They spew matter out. In today's video, we're diving into the fascinating and mysterious world of the white hole theory. What is a white hole? A white hole is a hypothetical region in space where matter and energy can escape, but nothing can enter. If black holes are the ultimate cosmic vacuum cleaners, then white holes are the opposite, cosmic fountains that theoretically expel everything. In simple terms, while black holes trap everything in their gravitational pull, white holes do the reverse. They push everything away. Here's how it works. In a white hole, the force of gravity is still incredibly strong, but instead of pulling things in, it acts as a barrier, preventing anything from getting close. Anything inside the white hole is forced out at high speeds. The connection between white holes and black holes. White holes aren't just random phenomena. They're theoretically linked to black holes through a concept in Einstein's theory of general relativity. Some physicists believe that black holes and white holes could be two ends of the same cosmic object, with the black hole acting as the entrance and the white hole as the exit. This idea is connected to wormholes, hypothetical tunnels in space-time that link different points in the universe. The theory suggests that matter entering a black hole could, in theory, travel through a wormhole and be ejected from a white hole somewhere else in the universe, or even in another universe entirely. What does the math say? Mathematically, white holes can exist within the framework of Einstein's field equations, the same equations that describe black holes. In fact, the math for white holes is nearly identical to that of black holes, except for one key difference: the flow of time. In a black hole, time runs forward as we know it, pulling matter toward the center. But in a white hole, time seems to run backward, pushing matter away from it. This concept is incredibly complex and theoretical, but it's what makes the idea of white holes so intriguing. Have we ever observed a white hole? While black holes have been observed indirectly, through the gravitational effects they have on nearby objects and the light they warp, white holes remain entirely hypothetical. No direct evidence of a white hole has ever been found. However, there are some intriguing possibilities. In 2006, astronomers observed a mysterious burst of energy from a distant region of space. Initially thought to be a gamma-ray burst, this event didn't behave like any known phenomenon. Some scientists speculated that this might have been the first observational evidence of a white hole. However, the event was too brief to confirm. Some physicists have even proposed that the Big Bang itself might have been a white hole. In this theory, our entire universe could have emerged from the explosion of a white hole. This would explain the massive outflow of matter and energy at the beginning of time, similar to how a white hole expels everything from within. If this theory holds any truth, it means that white holes might not just exist in distant galaxies. They could be responsible for the creation of the universe itself. The reason we haven't discovered white holes might lie in their extreme instability. White holes, according to theory, could only exist for an incredibly short time before they collapse or dissipate. Unlike black holes, which can persist for billions of years, a white hole might appear, eject its contents, and then vanish almost instantly. There's also the possibility that white holes are purely mathematical constructs, with no real physical existence in the universe. While the math suggests they could exist, that doesn't necessarily mean they do. Even though we haven't observed a white hole, the theory behind them raises exciting possibilities about the nature of our universe. Could white holes be gateways to other universes? Are they linked to black holes via wormholes? And if the Big Bang was a white hole, does that mean there are other universes born from their own white holes? While these are still open questions, the white hole theory continues to inspire physicists to explore the deeper, more mysterious aspects of space, time, and the nature of reality. White holes may be one of the most mysterious and least understood phenomena in modern astrophysics. While we haven't found one yet, the theory behind them opens up fascinating possibilities for how the universe works, and what might lie beyond the realms of what we can observe. Whether or not white holes are real, the idea keeps pushing the boundaries of science. And that's exactly what makes space exploration so exciting.